Hi there, this is Cross Product 3D Problem, and I'm actually redoing this one because, like most people, you're going to make an error about 10% of your problems, no matter how complex they get. So, well, let's just start over. We got this problem here. Jimmy got his kite stuck on a street light. If Jimmy pulls on the string with a force of 10 pounds, what is the moment at point O? And point O is at the base of this light pole. And once again, you're just going to have to kind of forgive me for the terrible drawing. My art is terrible, and it always will be for pretty much all these videos. So, one thing that we need to realize is that the moment about that point O, moment O, is going to be R cross the force vector. So now we just need to determine what these two are, and then we can do the cross product like usual. Well, R is actually already pointed out here in the as a dashed line in the center of the drawing. So I'm just going to actually write it. Our R vector is going to be 25 up and 8 in the z direction. So that would be 25j hat plus 8k hat. That one's simple. That's just what the lamp is actually literally doing. Now this force vector, and thank you again, whoever, I think it was Ice Pack, I think that's who it was, they kind of informed me that I was, that I might have been doing something a little bit flawed. I'm going to show you a little technique of how to split up or find out, no matter if it's a 3D problem or 2D, how to find the component and then you multiply it by your magnitude. So here, let me do that real quick. Basically, what you should do is we should find essentially the direction of the force, okay? And that is going to be a vector, okay? But that needs to be 1. So what I want you to ask yourself is, what does this equal? Well, this equals the force vector over the magnitude of the force vector, okay? So that essentially all it is a directional component, that you're just getting the direction, you're no longer getting the magnitude, you've divided the magnitude out. So, well, what does that look like? Well, that's just, we'll keep going. This force vector, let's just decide what this force vector would be. I'm not going to call this a force vector right here. Really what this needs to be is this needs to be geometry based, okay? So we should be calling this like K to the light, so K to L or something like that. So realize that that is really just K to L. And we're just trying to find some basis of the geometry, right? So K to L, this whole thing will be equaling a triangle. So we know that this will be 8 and this is 23. That's 25 minus the 3 feet, so that's actually 22. 22 feet and 8 feet. And then you could work that out as 8 squared. You would do the Pythagorean theorem. I could do it for you guys, but you know, c squared equals 8 squared plus 22 squared, and that will equal, let me just do it for you guys real quick, 23.4. And that's essentially like, almost like saying that's the amount, that's the length of the string between Jimmy's hands and where it's actually attached to the lamp. So this is 23.4. So how do we find the components? Okay, let's go back to our KL over on what I'm just going to call the magnitude of KL. Okay, so now what you can do is you can actually say Well, we know that it's going to be 8 in the negative x direction, right? So we know it's going to be negative 8i. And we know it's going to be negative 22j, right? That's just from the geometry that you find right here, right by the kite and Jimmy, and it goes 8 foot and the negative x, and just keep referring to our coordinate system I have set up kind of over here in the corner. Okay, all divided by our magnitude that we've come up with just now with the Pythagorean theorem, 23.4. This has actually come up with a portion that, almost like a component, that the force of that 10 pounds, if that makes sense. So basically it's going to be negative 8 over 23.4 in the direction of I, right? This is the component. This is going to be your direction of F. That's going to be your I, and then you'll have minus 22 over 23.4, and that'll be J, okay? So realize that these are both going to be less than 1, because when you square them, when you square each value, it should equal 1, because remember that these vectors, no matter what they are, they always equal 1. Like the total vector does, not each component, but the total vector. So just, you have to kind of recall some of that. So now, what we're going to do is, we know that he's pulling, it's going to result in a force vector of 10 pounds. So, we take this direction and we multiply it by the applied force, 10 pounds. So, let's look at that again. You have your directional force, which is going to be multiplied by, which I'm just going to say multiplied because it's scalar, 10 pounds. Because this is actually the magnitude, 10 pounds. Because this portion is the direction, this portion is the magnitude. All we were doing is we were using the geometry to determine the direction the force was going to go in, and then we divided it by the length. Or no, then we just multiplied it by the force, the magnitude of the force. So all we needed to do, let me recap, all we needed to do was look at the geometry that we found just from looking at Jimmy and the kite and the light, and we determined what direction that force was going to go in, and then we multiplied it by 10 pounds once we came up with that direction. And remember, directional vectors always, when you do the Pythagorean theorem on them, they always come up to 1. So you just have to remember that. So it doesn't change the magnitude at all, just the direction. So, since we already found out our directional vector, we just need to multiply that by 10. So, I'll just do that right now for us. Let's just come up with what these each are real quick. I'm going to say that this negative 8 divided by let's see here. Okay, so you have 23.4, that's going to be it, so negative 8 divided by 23.4. So that's going to be negative 0.3418, or 19, whatever, I. Okay, then, well, no, it would be minus again, right? 22 divided by 23.4, which is going to be about 90.94, right? Yes, if you did square root each of these, it would equal 1. Just trust me, pretty close to it. I did do a little bit of rounding. So now, what we need to do is we need to find out what that force is, and then do the square root on it. So let's do it real quick. We got this. Our force vector is now going to be equal to times 10 of this, 3.419 I, minus 9.4j. This is our force vector. Now we just do the simple stuff. I hat, j hat, k hat, okay, and then you do our r vector, which we found earlier. It was a simple one, 25, 8. This one is going to be 3.42, then negative, and that should be negative, and this should be negative 9.4, this should be 0. So now we just have to essentially run through it. And you just do the math just as you did before, and I don't want to stress you guys out. You guys know how to do a lot of this, but all you do is you do the cross product and you get your solution.